So here we go. Combustion reactions is our fifth type of reaction. If you guys remember back at the beginning of this unit, I said there'd be 5 types of reactions. Well, we've had synthesis, decomposition, single replacement, double replacement, and now combustion. Said to use my other hand because my thumb's too short. There's our 5 types of reactions. There are going to be some things you guys like about combustion reactions and some things you don't like. Sorry. But also you're welcome, both. All right, here's what you guys are going to like about these reactions. They always form the same thing. So you never have to think about the products. You don't have to worry about balancing subscripts. You don't have to worry about matching positives with negatives or think about who's going to replace who. You don't have to do any of that. The products are always carbon dioxide and water vapor. The hydrocarbon part comes from last chapter, organic chemistry. Those are all of our hydrocarbons. So you're going to have to kind of remember a little bit from last chapter for that part of it. But you're always going to form carbon dioxide and water vapor. Kind of a little catch here. So quick note on the water vapor. This whole unit, I've kind of been telling you guys, water is a liquid. We should all know that. Yes, water is almost always a liquid. We should always know that. But in these reactions, it's a vapor. You guys are actually more familiar with these reactions than you know. In fact, you're even more familiar with it than what I'm going to tell you right now. I'm not going to get into all that right now because a lot of it's biology, but combustion reactions, those are fire. Go light a candle. That's a combustion reaction. Have a campfire. That is a combustion reaction. Drive your car. That's a combustion reaction. So these are actually reactions that you guys are really familiar with. We're having a fire. What you never think about is water being a product, right? Like we usually think of like a campfire. You put water on it to put it out. But it's actually also being produced. The reason why we never think about it is because there's so much energy, it's coming off as a gas. We don't see it. It's a vapor. But yes, in all of our fires and all of our combustion reactions, water is coming off of it, water's coming out of it. We just usually don't see it because it's a gas. General formula, not hydrocarbon, hydrocarbon. Again, this part you're not going to like. It's from last chapter. You're going to have to remember last chapter. But the rest of it, pretty easy. It's always going to react with oxygen, and it's always going to form carbon dioxide and water vapor. So your equation is always going to look like this right here. So again, part of it you like, part of it you don't like. For example, very basic hydrocarbon, methane, CH4, carbon, hydrogen, that's a hydrocarbon, plus oxygen. And again, that's where it gets easy. I think we all know oxygen's a gas. If you aren't really sure, take a deep breath. Carbon dioxide, always produced. Don't need to think about it, just have to write it. Carbon dioxide, also a gas. Again, if you aren't sure about that, exhale. And water vapor, that's water as a gas. So again, these reactions are always really easy because this is always going to be the same on the back half. Always the same back here. All right, now the next part you guys aren't going to like. Balancing can be a little tricky. I'll give you guys some examples, but just stick with it. I'll try to give you guys some pointers as we go. Carbon, one carbon, good start. 4 hydrogen, only 2 hydrogen, so to fix that, put a 2 out in front, there we go. Now 4 hydrogen and 4 hydrogen. 2 oxygen, I've got 2 there and 2 more there, so that's 4 oxygen. So to get the 4 oxygen here, we have to put a 2 there. Cool, there we go. 1 carbon, 4 hydrogen, 4 oxygen, 2, and 2 more is 4 oxygen. All right, that one wasn't so bad. Methane, might as well put it in. Methane is a small molecule, it's a gas. Normally you'll be told what the hydrocarbon is. Questions so far? Cool. Let's take a look at another example here. So this is what it looks like on our homework. Here's the part you're not going to like. And there's 2 parts you're not going to like and 1 part you will like. We have to remember what ethane is. And guys, I do this. I've been doing this for 20 years and I still have to do this. So don't think you can just take shortcuts. I have to write this out. F is 2 carbons. A and E tells me it's all single bonds. So I need to fill the rest up with hydrogens. Again, I've been doing this for 20 years and I still have to draw that. I don't know off the top of my head what the chemical formula for ethane is. So just get in the habit of doing that. It takes an extra minute. Like I said, you're not going to like that part, but it's a part of solving these problems. All right, why did I do that? Well, now I can count. 2 carbons, 6 hydrogens. It tells me it's a gas. Might as well use that knowledge right off the bat. It's a gas. The rest of it is pretty easy. It's going to react with oxygen. It's going to form carbon dioxide and water vapor. So that's the easy part. That's simple. We don't have to think about the products. We don't have to balance for charge. We don't have to look charges up. We don't have to worry about polyatomic ions. That part's easy. The hard part is remembering your organics. And then now balancing. This can be kind of a trick. I'll try to make some pointers for you guys. 2 carbons, 1 carbon. Okay, I can fix that pretty easy. There we go. Now I've got 2 carbons and 2 carbons. 6 hydrogen. Only 2 hydrogen. Okay, well, how do I get from 2 to 6? I multiply it by 3. Cool. So now I've got, let's see, I've got 6 hydrogens, and 3 times 2 is 6 hydrogens. Now I'm ready for my oxygen. 2 oxygen. I have 4 there and 3 here. That's a total of 7. Guys, we've got a problem. We can't get to an odd number when we have 2. We're not using half numbers. And by the way, thank you, or you're welcome for that. Don't have to use half numbers. Can you imagine how complicated it'd get if you started using fractions and decimals? Oh, so we're not doing that. We can't put a half number. When that's the case, start over. Double your hydrocarbons. Just go back to the beginning. Don't start playing around with it. Don't start trying to balance this, that, and the other thing. Just start over. Go back to your hydrocarbons. Double it. I've now got 4 carbons. So there's 4 carbons. I now have 12 hydrogen. 2 times 6 gives me 12 hydrogen. Now I'm ready for my oxygen. All right, I've got 8 here. 4 times 2 is 8. And 6 more, that's 14 oxygen. Hey, that's good news. I can get to 14. I get to 14 by multiplying it by 7. Whew. Like I said, these can get kind of complicated when you're balancing. You won't like that part. But predicting the products, pretty easy. I don't think we've seen a 7 yet, and all the homeworks we've done, probably not very many 6s either. So yeah, the numbers can get big, but I think we're okay. I think we're okay. Just remember, double your number of hydrocarbons if you can't get your oxygens to work out. Don't play around with those oxygens. If they're not going to work, they're not going to work. We'll do one more example. So this time we're writing the balance reaction for the combustion of liquid ethanol. A little different this time. We've got that OL ending. So we got to remember what that was from last chapter. We'll start with the eth part though. Eth means 2. So there's my 2 carbons. OL, that's an alcohol. OL tells us alcohol. So there's an alcohol, an OH. The AN tells us it's a single bond. So that's good. So we just got to make sure our carbons all have 4 bonds now and fill all those bonds up with hydrogens. All right, again, why do we do that? Well, we do that so that we can come up with the chemical formula. 2 carbons, 6 hydrogens, and 1 oxygen. There's the chemical formula for ethanol. Hey, the question told me it's a liquid, so let's just get that out of the way right now. There we go, liquid ethanol. The rest of it's pretty easy. It's going to react with oxygen. You need oxygen for a fire to go. And it's going to form carbon dioxide and water vapor. Okay, so that's the easy part, predicting products. But now we have to balance it. I always start with the carbons. I've got 2 carbons. Make this a 2. And there we go. 2 carbons and 2 carbons. Hydrogen, I have 6. Over here, I've only got 2. How do I get 2 into 6? I multiply it by 3. There we go. 6 hydrogen, 6 hydrogen. Now we're ready for the oxygen. I've got 2 on this side, 4, and 3 more is 7. This is actually not the same problem we had up above, though, because look, we've got that 1 oxygen right there. I can get an odd number this time. It's okay that I have 7 because I've got the odd number 1 right there. So subtract 1, that 1 from 7, we get down to 6. I can get to 6. There it is. And voila, this one's balanced. It looked worse at the beginning. It ended up being actually a little bit easier.